So this is the third video covering activity 4.5. I believe the last video we ended with example 4. So we have the negative 20x cubed minus 15x. Now this problem is different than the previous two examples. See, notice how in this example there's an x in each term. Where if I look at example 3, there was an x in the first term, the second term, but not the third term. Right? Or in example 2, there was an a in the first term, a b in the second term, but the same letter or variable was not in both terms. Example 4, you have the same variable in each term. So when that happens, you want to factor out the biggest number that appears in each term and also the variable with the smallest exponent. So remember, this is really like an x to the 1. All right, so we have x cubed and x to the 1, so you take out the x to the 1, or you factor the x to the 1. Right, so the book, they did negative 5, right? So negative 5 goes into negative 20 and negative 15 evenly. So they factor out a negative 5, and then you also take out the variable with the smallest exponent. So my choice is x cubed or x to the first, so I take the x to the 1 out. And then what are you left with? Well, if I divide each piece by negative 5x, right, the first term, I would be left with 4x squared. And the second term would leave me with just 3, or positive 3. Right, so that's what we get, and that's what they have. But there's another way to handle this problem. All right, so let me erase some of my markings. So the other way to handle this is, instead of factoring out a negative 5x, what happens if I factor out a positive 5x? Well, that would work also, right? So if I factor out a positive 5x, I have to divide each piece by 5x. So what am I left with? Negative 20x cubed divided by 5x is negative 4x squared. And the second term would leave me with negative 15x divided by 5x is negative 3. Okay, so this answer, that's a squared, right? So this answer is actually the same, right? These two answers are the same, right? Just the signs change, because think about it. 5x times negative 4 is negative 20x cubed, and negative 5x times 4x squared is still negative 20x cubed. See, so I would accept this answer or this answer. Either one is acceptable. Generally, we try to keep the x squared term positive, so this top one is preferred. All right, let me erase some of these markings. Okay, so again, I would accept this, and I would accept either of these two answers. But generally, I prefer this one up top because the x squared term is positive. I prefer 4x squared instead of negative 4x squared. And I'll explain why as we continue through activity 4.5. But for the purpose of a test or a quiz, either of these would be acceptable. Okay? Okay, so now let's practice a few of these problems. We won't do all of them. Maybe we'll start with some of the even problems. So when I look at number 12, what is the biggest number that goes into 3a and 3b evenly? Well, that would be 3. And if I divide each piece by what I just factored out, I'm going to be left with a minus b on the inside. So that would be my answer, 3 times a minus b. If we look at number 14, the largest number that goes into 14 and 21 would be 7. And whatever I factor out, in this case, I'd factor out a 7, so divide each term by the 7, and you're left with 2x minus 3y. Okay, so that would be my final answer, 2x minus 3y. All right. If I look at number 16, okay, so I have 5t cubed minus 6t squared plus t. All right, so now this is different. I have a t in each term. So the biggest number that goes into 5, 6, and 1 is really just 1. So I can't, there's no number I can factor out, but I can factor out a t. So remember, you take the t with the smallest exponent. So you have t cubed, t squared, and t to the 1. So you factor out just the t. And when you divide each piece by the t, what do you have left? That's a t. All right, so then this would leave me with 5t squared minus 6t plus 1. Final answer. Right, and you might say, well, how do you get 1? Remember, t divided by t is 1. 6t squared divided by t is 6t. And 5t cubed divided by t is t squared, 5t squared. All right, and you can always check your work by distributing, right? If I distribute this t all the way through, I should end up with my original equation. All right, let's take a look at 18. All right, so 18, I'm going to take out the negative 5x. Right, because 5 is the biggest number that goes in each of these. And I want to make the x squared positive, so I factor out a negative 5. And then I have x squared and x to the 1, so you take the x with the smallest exponent. So you're going to be left with, right, you divide each of these by negative 5x. And you're going to be left with 2x plus 1. Right, that's my final answer. Now, you might say, well, what would happen if I use positive 5x instead? All right, if I factor out a 5x, you would have negative 2x minus 1 inside. Okay, so not much of a big difference, right? Just the signs change, right? If this becomes a positive, well, then everything else, the signs are reversed, so we get negative, negative. Okay. Last one, number 20. I'm going to factor out a negative 16t. So divide each term by negative 16t. It's a little sloppy. So what are you left with? This would give me t squared minus 4t plus 2. And that would be my final answer, right? And you can always check your work, right? Negative 16t times t squared gives me negative 16t cubed. Negative 16t times negative 4t gives me positive 64t squared. And negative 16t times 2 gives me negative 32t. So it all works out. So I think we'll stop here, and in the next video, we'll talk about factoring trinomials.